Hey there, everybody. Hi, kids. We're jumping into lesson 3 today. So, module 3, lesson 3, and the objective is to add fractions with unlike units by creating equivalent fractions. So, if they don't give you something that has a common denominator, we're going to make our problem have common denominators. So, the idea behind this is that if you have something that is labeled like similarly. So 1 adult plus 3 adults, you can add those groups and there aren't any problems. You get 4 adults. That's easy. But so same units can be added. But what if you have different units? And so this is what you might notice if you have 1 child plus 3 adults. The ticket prices are different. So how do you do that? Well, if you label it with something that works, then you can continue to add and it's not a problem. Change the child and adults to people and then you can put it all together. So that's just kind of a simple way of explaining what we're doing when we make like units. So how do you do this? Well, you're going to need to use a scale factor. And what that is, a factor is a number you multiply. So we're going to choose a scale factor that will help us get a common denominator. Now, it's not that hard, and at first we're going to do something like this. Look at, sorry if I show you the right ones, 1/2 plus 1/4. If you look at these two, you can always multiply these two numbers to get a common denominator. Okay, that will always work because whatever you multiply and get, of course, both of these will be a factor of what you get because that's what these are. They become factors. So if you then convert these to equivalent fractions, then you have like denominators or like units, and then you can add them. And then we can talk about simplifying a little bit later. I'm not going to really hit that too hard today. But just know that we can simplify and put things in simplest form, air quotes. This is still equivalent to 3/4, and that was kind of with our fraction strips. You should be able to see what is equal. Okay, now up here we have 1/2 plus 1/4. Today we're going to be making these models on paper. So it's going to look like you're making two separate things, but when we combine them, it's going to be kind of a cool design. I'll show you when we get in the book how to do that, but you're going to make equivalent fractions, combine them when adding, and now you will have created equivalent pieces so that you can add. This again is the simplifying, so don't worry about this too much now. We're just going to be focusing on adding. And then finally at the bottom here, this is really what we're going to be doing, but you won't have to draw quite this much. I just always overdraw it so that you can see my step-by-step thinking. Let's take this model of 1/3 plus 1/2. You will take halves this way and lay it over your 1/3 model so that you'll create a new picture. And in doing so, you'll create this equivalent fraction. It'll be the model of the equivalent fraction. I'll show you when we get into the book. This one, if it's 1/2, half being shaded, you'll take what you did over here and lay it over the top of this by making thirds. And in doing so, you'll create a visual model that is an equivalent fraction to this one. Now that you have a common denominator, you can simply add. Now, what happens if sometimes you add and you get a really big top numerator? So in this problem, 2/5 plus 2/3. If you, again, multiply these, you would know that you'll end up with 15. So what I do is I say, okay, take the opposite number, multiply both the top and the bottom, and then if you do 2 times 3, you get 6, and 5 times 3 is 15, and 2 times 5, because you're multiplying this bottom number by everything over here, 2 times 5 is 10, and 3 times 5 is 15. Now I have a common denominator. I can add 6 plus 10 and get 16, but we have the 16/15, which makes these very strange looking improper fraction. And so that's when you have to remember so many steps here. 16 is really divided by 15. That's a division bar. And that goes one whole time. You can fit 15 into 16 one whole time with one left over out of my set of 15. And so that is what we're doing today in lesson 3. Sometimes, kids, if you have a piece of paper and you want to cut it out, this is what is in the teacher's edition as far as what you can do. If you don't understand making the equivalent fractions after you have laid over the model, just cut out the pieces so that you can literally place them onto this model so that you can see the total. And I know it's kind of cut off there at the bottom, but that's just another sample problem too. If you have extra pieces of paper, you can do that. So let's jump in. Okay, draw a rectangular fraction model to find the sum. Simplify your answer if possible. It's really important that you follow these directions in this order. Draw a box. Now the first model will be vertical. Shade half. Okay, this is what I'm creating a model for 1/2. Okay, now let's create a model for 1/3. But this model will be horizontal. Just do it, trust me. Okay, 1/3 shade. Now in the beginning for this one, I'm going to show you twice, but I won't be doing this forever. I'm just going to show you again. Now, what I'll be doing from now on is I'll take this model and this one. So I'm doing it again just to show you what's going to happen here. Okay, now from now on I'll only do it one time. I'm going to take my thirds and I'm going to restripe and I'm going to shade, but I'm going to, oh sorry, I'm not shading yet. Whoop, we're not multiplying fractions. And then I'm going to take this one and I'm going to make halves. So whatever was this model, lay over the half onto thirds. And then for this one, lay over thirds on the 1/2. Okay? Now you can see that you have equivalent fractions. Because I could not add these before because they were different, now I can see that I have 3/6 and 2/6. And so I have created this equivalent fraction with like denominators, and I can add them and get my answer. So ta-da! So that's what we're doing. That one takes up a lot of space, but the rest won't be quite so busy until you get into many, many pieces. Okay, 1/3, again, straight up and down, plus 1/5. Try to keep up. If I go too fast, just slow it down. 1, 2, 3, 4, 5. Shade 1. Sometimes the book, I think they shade the bottom one. I don't know, I can't remember. Irrelevant. Now I'm going to take the fifths and I will lay them over onto the thirds. And I will take the thirds and lay them over onto the fifths. And now you can see the equivalent number that is shaded in each one so that you can add. Now, another important thing to think about is how many pieces do I have? When you do this laying over process, you are making fifths out of thirds, which means you're multiplying those two. So I should have 15ths for each of these. Now, when you check your model, you can go 3 times 5 is 15. 3 times 5 is 15. So there's a whole bunch of kind of mental checking as you go on. Now, how do I know what the top number is if I'm not having a model or I'm not counting it like 1, 2, 3, 4, 5? I can see 5, but how do I know mathematically? It's because I'm taking 1/3 and I'm multiplying it by this denominator as my scale factor, and I'm getting 5/15. And that's what I'm going to do here too, but I can see that I have 3. So for today, we're just kind of putting these together and saying, let's make like units. Okay, and then let's do more models. Vertical for the first model, 1/4 plus 1/3. Horizontal for the second model. Now lay over thirds, 1, 2, 3 sections, and lay over fourths. I always do half the left, half the right when I make fourths. See the equivalent. How many pieces do I have? 4 times 3, it's 12. You can always count them, but that's a drag. So I know I have 12ths. I have 3/12 here, and I have 4/12 here. And those are the equivalent fractions to what I had up on top. 3 plus 4 is 7, and we're done. 1/3 shade plus 1/7 horizontal. Okay, it's a challenge. 1, 2, 3, 4 should be a little more than halfway. 5, 6, 7. So you just kind of eyeball it. I know I've been doing it for a while, so I usually can crank these out pretty quickly. Now lay the opposite one over, so I need 7ths here. 1, 2, 3, 4, 5. Last one goes 6, 7. And then thirds is just 2 lines. And now we have, again, if you're multiplying, I know 7 times 3 is 21. Because after a while, you're going to have so many parts, you'll be like, I don't want to count all that. Okay? So how many are shaded here? 7. And the cross, I forget what it was. It was like a cross multiplying, I think is what your parents will probably say. It's really like it's 3 times 1 to give you 3, and then over the 21, and then 7 times 1 to give you the 7. But I haven't done it in so long. It's like I've been doing this new way for too long now. Almost forgot the old way. So you end up with 10 21sts. Okay, turn the page. Got more stuff on the back. Now this side, we're starting to get into multiple shading, not just one part, but maybe 3/4. So just make your model. Make it in fourths. The denominator tells you how many parts or how many pieces. Okay, that's what the bottom tells you. And the top tells you how many to shade. Okay, so this one says shade 3 out of 4. Make 4 and shade 3 of them. Okay, and to that we will add 1/5. So I need 5 parts, 1, 2, 3, 4, 5, and shade 1. And then still do the laying over of the lines. I need 5 lines now here, or well, 1, 2, 3, 4, 5, 4 lines to make 5 sections horizontally. And then I need fourths over here, so cut it in half, half the left, half the right. Now I have fourths. And 4 times 5 I know is 20, so that's how many pieces I should have in each one if your models are good. And when you are multiplying, again, you've made this 5 over the 4, so you're making an array. This is just like 3rd grade math, but it's how many are shaded instead of 4 times 5. That's our full set here. If it was 20 over 20 pieces, that would be the whole thing. But it's 3 times the 5, so that's 15. And so just mathematically kind of think about and check and make sure that you're putting in good answers. You don't want to put like 16 here. That would not obviously be good. So don't just rely on counting. Do the math as well. And then this is going to be 4/20, which is equivalent to 1/5. So we're making equivalent fractions so that we can add. And I get 19/20. Last one. 2/3 are shaded. Plus 2/7 this way. 4, 5, 6, 7. Let's pretend they're all the same size, and I want them to be shaded 1 and 2. Doesn't have to be perfect. Don't take forever. Now we make 7ths on this one. 1, 2, 3, 4, 5, 6, 7, and make 3rds on this one. 2 lines makes 3 sections. Okay, so we have 2 out of the 3 parts. We know we have 21 on the bottom for both. And then this is now 7 plus 7, which is 14, or 7 times 2, which is 14. And then this one had 3, but now it has 6. So, or it had 2 sections, my bad. 2 sections, but now we split it by 3, so 2 times 3 is 6. Then 14 plus 6 is 20, and you have your 20 21sts. Okay, let's move on. Solve the following problems. Draw a picture and write the number sentence that proves the answer. Simplify your answer if possible. Okay, I haven't looked at these in a year. Okay. Jamal used 1/3 of a yard of ribbon to tie a package and 1/6 of a yard of ribbon to tie a bow. How many yards of ribbon did Jamal use in all? So first of all, I'm always thinking about, do they have like units? I have 1/3 plus 1/6, and I need to make a model of each one. Okay, 2 quick squares, 1/3 and 1/6. Cut that in the middle and do 3 sections on top and 3 sections on the bottom. Okay, so there's our model. Scribble, scribble. Lay the 6ths over the 3rds. 1, 2, 3, 4, 5, 6. And lay the 3rds over the 6ths. And now we have 18ths. And I had 1 before, but that's times 6 now, so now it's 6. And then I had the 1/6 before, but now I have 3. And so I add these, and we'll get into simplifying a little bit later. I have my own rules. I have a big poster that I put on the wall, and they're like Mrs. Setness's rules for simplifying for 5th graders. But anyway, this is what I call, it's like a double from the top to the bottom. And so rule 1 is look for doubles, and this is always equal to 1/2. It just means you can divide the whole fraction by the top number, and 9 divided by 9 is 1, 18 divided by 9 is 2, and you will get that. So it's just one of my silly little things. Oops, and how many yards of ribbon did Jamal use? Jamal used 1/2 yard. Always label your answer in a word problem of ribbon. There you go. And then moving on. Over the weekend, Nolan drank 1/6 of a quart of orange juice, and Andrea drank 3/4 quart of orange juice. How many quarts did they drink together? Again, quarts, quarts, and quarts. So check your amounts. 1/6 plus 3/4. But we can't combine amounts when they don't have like amounts. And I could go on and on about trying to find the lowest common denominator, but today we're just making models. And the lowest common denominator between these two would be 12, but we're going to end up multiplying. So make your vertical model, and we'll talk about that in another video. Don't really have time for that today. We're just making equivalent fractions, and the horizontal model needs to have 3 shaded. 3 on top says shade that. Now lay over the fourths onto the sixths, and lay over the sixths onto the fourths. And now we know we have 24 pieces in each one. And if I was to do my cross multiplying or just recognize how many parts I just created out of each one, I would end up with 4 24ths and 18 24ths. And I end up with 22 24ths. Oops, 4. I said 4. I said 4, hand, right? 4. Okay, so at this point, some students will say, yay, I'm done. And I am always like, they're both even. You could simplify that. I just always want to simplify. And so to simplify, look for, oops, got something wrong with his eye. Look for a common denominator. And that, my friends, is rule 3. Mrs. Setness is rule 3. Look for a common denominator. And guess what rule 2 is? Look for numbers that are even. Even numbers are always divisible by 2, so you could start out with, if nothing else, just dividing by 2. And if I was to use 2 as a scale factor for each number, I could end up with 11 twelfths. And that, my friends, is the simplest form for this answer. And I can't leave it like that. It's not okay. They drank blah of OJ together. Okay, delicious. Okay, moving on. Last one. We're almost done. Nadia spent 1/4 of her money. Sorry, I guess that makes a lot of noise when I do that. Nadia spent 1/4 of her money on a shirt and 2/5 of her money on new shoes. What fraction of Nadia's money has been spent? Always watch out for questions like, well, now what is left? And then we're going to talk about what is a whole, W-H-O-L-E. So she has money and she spends 1/4 of it, and then she spends 2/5 of it. So this is all the spent money. So let's make a model for each. And 1/4 is like so, plus 2/5 is like so. 1, 2, 3, 4, 5. 2, 1, and 2. Now lay over the opposites so that we can create equivalents. So 5ths, 1, 2, 3, 4, 5, taking that 5 and putting it over here, and take the 4 and put it over here. 4ths. Now we have 20ths in both. And if you multiply or cross multiply or just count your pieces, you will have 5 here, and you will have 8 here. And when you add 8 and 5, I added that wrong on one of the videos, and I was like, I don't know, I went back later. Anyway, 13 20ths is spent. And so it's asking about the fraction. Sometimes they'll actually give you a money amount and you have to figure that out, but today it's just what is spent. Now what is left? So here's the key. All the money, since we don't have an amount, would be 20 20ths. Okay? Easy enough, right? All the money is out of 20 parts of the money, whatever it is, then keeping 20 parts. So this is the whole amount. If you subtract what is spent, then you have what is left. And so 20 minus 13 is 7. And so 7 20ths is left. Cool, right? So that's that. That's, and I hope there's nothing left. Okay, that's that. Yay, for real. And if these videos or this one in particular is helpful, click subscribe. And I'm really trying my best to keep up with all these lessons, at least a lesson a day. And so I will see you guys on the next one. Have a great day.